Hi everyone, let us discuss this example. So in this example we have y is equal to e raised to m cos inverse x and we have to prove these two things. Okay, so let us focus on first part. So let me write what we have. We have y is equal to e raised to m cos inverse x. As you can see here, we want y2, that means we want a second derivative of y. So let us take derivatives. We will take two derivatives one by one. So let us differentiate with respect to x. Differentiating with respect to x, derivative of y is y1. So the first function is exponential function. Derivative of exponential function is same. Derivative of e raised to x is e raised to x. So it will be e raised to m cos inverse x. After that we have to take derivative of m cos inverse x. Okay, m cos inverse x. Let us find e raised to m cos inverse x into, what will happen that m will come outside. It is a constant, so it will come outside. So we will have m outside, and derivative of cos inverse is minus 1 upon square root of 1 minus x square. So let me write it here, minus 1, that means minus, I will write it here, square root of 1 minus x square, right? So this is y1 is equal to, this is value of y1, but we are interested in y2. So that means we have to take one more derivative. But see, wait, what will I do? I will shift this square root here. Since if you take derivative directly, then you have to use u upon v formula. So instead of that, I will shift this square root on this side, then it will be very easy to find its derivative. Okay, so let me write it there. Just a minute. Okay. So let us shift this square root on this side. So square root of 1 minus x square y1, okay, y1 is equal to minus m e raised to m cos inverse x, right? But we have seen this m e raised to m cos inverse x somewhere. It is y, okay, so we can replace it by y. So it will be square root of 1 minus x square, okay, y1 is equal to minus my. So let us differentiate now, since we are interested in second derivative. Differentiating with respect to x. Differentiating with respect to x, then what will happen? We have to take derivative of left hand side, but there is a product of two functions, so I should use u into v formula. First into derivative of second plus second into derivative of first. That formula I will use. First, as it is, I should write 1 minus root 1 minus x square. Derivative of y1 is y2. Now y1 as it is, and we have to write derivative of square root of 1 minus x square. You know that derivative of root x is 1 upon 2 root x. That formula I am applying. So this is 1 upon 2 root 1 minus x square. But again derivative of the term which is lying inside the square root. So derivative of 1 is 0 and derivative of x square is 2x. So there is minus sign, minus 2x. This is equal to derivative of left hand side, sorry, right hand side. Minus m is a constant, will come outside. Derivative of y is y1. Okay. So yes, most of the things we have done. But see, I don't want this square root at denominator. So I will multiply both sides by square root of 1 minus x square again. So see, multiplying both sides by root 1 minus x square. See what will happen? Root into root will get cancelled. So 1 minus x square only, y2. If you multiply this root to this one, so root will get cancelled. 2 also will get cancelled, and you will have minus sign is there. No, I should write here minus x y1. If you multiply minus m y1 root 1 minus x square. I think we have seen it somewhere. Yes, see, root 1 minus x square y1, root 1 minus x square y1, its value is minus my. Getting, so its value, I should call it as something. I should call it as equation number 1. So I am going to use equation number 1. 1 minus x square y2 minus x y1 is equal to minus m. Its value is minus my from 1, okay, from 1. So 1 minus x square y2 minus x y1, minus plus, okay, m into m square y. Yes, we want the same, right? Yes, we finished the first part here. We finished the first part. Let me highlight it. Yes. So in this way we finish the first part. We have to go for the second part. As you can see here, n plus 2. That means we supposed to find the nth derivative now. Let us take nth derivative. See, taking nth derivative of both sides. Taking nth derivative of both sides. Okay, see what will happen if you take nth derivative of both sides. Now let me write here. So this first term we have 1 minus x square y2, we have to take its nth derivative, minus x y1, this is next term, we have to take nth derivative, m square constant outside, derivative of nth derivative of y is 1. Okay, so now we have to find their derivatives, but as you can see there is a product, and when we have a product and we have to take nth derivative, we go for Leibnitz rule, right? There is no more space to write. Make a screenshot of it first, then I will go further. So let us find nth derivative. Okay, so Leibniz rule I will write it here. So by observing it we can easily find nth derivative. So it is, we write u as it is, nth derivative of v, nc1 u1 vn minus 1, nc2 u2 vn minus 2, nc3 u3 vn minus 3. In this way we calculate. At the end we will have ncn un v. Okay, so this is our Leibniz rule. This Leibniz rule I am going to use to find nth derivative of product of these two functions, right? What is our u? 1 minus x square is our u. What is our v? y2 is our v, right? Let us use Leibniz rule. So therefore u as it is, its nth derivative y2n, next plus nc1. See, as you can see, u1, u win, that means derivative of this bracket, its derivative will be minus 2x. Its n minus 1 derivative y2 n minus 1 plus nc2, its one more derivative, will be minus 2. Okay, its previous derivative, that means y2 n minus 2. See, after that again derivative of minus 2, that means we take a successive derivative, getting now. First we write as it is, derivative, double derivative, triple derivative, in this way we go. But see, derivative of minus 2 will be 0, so all remaining terms will be 0. Okay, this process we will stop here, but see, I should do the same process for second term, xy1. So for this one, xy1, what is my u? This is my u and this is my v. Okay, so let us apply Leibniz rule. So u as it is, x as it is, nth derivative of y1 plus nc1, getting na nc1, yes, a derivative of x1, its previous derivative y1 n minus 1, next derivative of 1 is 0, so remaining terms will be 0. We'll stop that process, m square yn. Okay, so let us simplify. So therefore 1 minus x square, see, simply we have to add, so yn plus 2, nc1, its value we have already seen in previous video, its value is n. So if you multiply to minus 2x minus 2nx y, simply you have to add, so 2 plus n minus 1, that means n plus 1. nc2, in previous video we have seen its value is n into n minus 1 by 2, so minus 2 I have written here, n into n minus 1 by 2. Okay, and if you add you will have yn only, minus, so x y n plus 1, nc1 is n plus n, if you add you will have yn only, is equal to m square yn. Okay, I don't have more space to write. Make a screenshot of it first, then I will go further. Okay, so let us simplify. 1 minus x square yn plus 2, right? See, yn plus 1 we have got, here also we have got yn plus 1. What will I do? I will solve the bracket first. Okay, next step I will do this thing, minus minus what we have, 2nx yn plus 1, 2 cancel, minus, if you solve the bracket, n square minus n minus x yn plus 1 minus n yn is equal to m square y. Okay. See, 1 minus x square y plus 2. Let us collect the terms of y plus 1. We have two terms, this one and this one. We can take minus x y plus 1 common. So in bracket you will have 2n plus 1. If you take x and y plus 1 common, what will I do? I will shift this term to that side. Okay, since as you can see here y term is in right hand side, so I will shift these two terms. Here also we have y, here also y. Let us shift them on that side. So n square minus n yes y plus n y plus m square y. Okay, I will write it here. So 1 minus x square y n plus 2, okay, minus 2n plus 1 x y n plus 1, okay. And see, if you take y in common, so minus n plus n will get cancelled and you will have is equal to n square plus m square y. I think this is the required answer. Yes, in this way we proved this part. Make a screenshot of it, then we will stop. Thank you. Bye bye.